Hello friends, welcome to our channel. Today we shall discuss the third problem on pedal equation. That is r raised to m is equal to a raised to m into sin m theta plus b raised to m into cos m theta. So our first step is to differentiate with respect to theta so as to eliminate the theta and obtain the pedal equation. So the first step is to differentiate the given equation with respect to theta. So we shall find the solution for this and obtain the pedal equation. So the first step is differentiating given equation with respect to theta. So we have, as we know that a raised to m, so differentiation of theta with respect to differentiation of r raised to m is nothing but m into r raised to m minus 1. So this is nothing but differentiation of a to the power x. So it is similar as a to the power x is nothing but x into a raised to x minus 1. Similarly, instead of a raised to x, we have r raised to m. So it is nothing but m into r raised to m minus 1. So we have, so differentiation of r raised to m is written as m into r raised to m minus 1 into, we have r. We are differentiating with respect to theta. So differentiation of r with respect to theta is nothing but dr upon d theta. Then is equal to, so we have a raised to m, keep a raised to m as it is, into what is the differentiation of sin m theta. So differentiation of, so the next thing is differentiation. So d by d theta of differentiation of sin m theta. So differentiation of sin theta is nothing but it is cos theta. So differentiation, we have sin m theta. So differentiation of sin m theta is nothing but cos m theta into differentiating with respect to theta, m into theta. So differentiation of m into theta is nothing but it is m. So therefore it will be m into cos m theta. Similarly, d by d theta. So differentiation of cos m theta. So as we know, the differentiation of cos theta is nothing but it is sin theta. So here we have cos m theta. So it will be sin m theta into differentiation of m into theta is nothing but it is only m. So it will be minus m into sin m theta. Okay. So therefore differentiation, we have a raised to m into differentiation of sin m theta is nothing but we have obtained m into cos m theta. So it is m into cos m theta. Then plus keeping b raised to m as it is, b raised to m as it is. Then because we are just differentiating with respect to theta, so a raised to m we need to keep as it is. So differentiation of sin m theta is cos m theta into m. Then similarly differentiation of cos m theta is minus. So it will be, we have obtained it as minus m into sin m theta. So then, so we have obtained the differentiation with respect to theta. So we have m into r raised to m minus 1. So this m minus 1, we can also reduce this. So because m into r raised to m we have, here there is a minus 1. So we can take it as denominator. So that is r raised to m, keeping r raised to m as it is. So therefore r raised to m divided by r. So this is nothing but r raised to m. If you take in the numerator, it will be minus 1. So just we are writing this in the form of r raised to m divided by r into dr upon d theta is equal to a raised to m cos m theta minus b raised to m sin m theta. We have eliminated this m because here we have m minus 1. So it is nothing but r raised to m into r raised to 1. So therefore we have written it as r raised to m divided by r, and we have taken m common. So we have taken m common, and this we have evaluated the equation to 0. So here we have m into, on the LHS we have m into equal to 0. So this m will be equal to 0. So therefore we can write this equation only in the form of r raised to m divided by r into dr upon d theta is equal to a raised to m into cos m theta minus b raised to m into sin m theta. So then again, so therefore again we have r raised to m divided by r. So we can just write it as 1 by r into dr upon d theta is equal to a raised to m into cos m theta minus b raised to m into sin m theta divided by a raised to m cos m theta plus b raised to m into cos m theta. One divided by r into dr upon d theta is equal to a raised to m into cos m theta minus b raised to m into sin m theta divided by, so this will be a raised to m into sin m theta plus b raised to m into cos m theta. We need to write in the form of cos and sin. Therefore, a raised to m cos m theta minus b raised to m sin m theta divided by a raised to m into sin m theta plus b raised to m into cos m theta. Then we shall now apply the theorem. So therefore, the theorem, it says that p is equal to r into sin phi, and one more equation is 1 divided by p. So what is 1 divided by p is nothing but, so we have p is equal to r into sin phi. So 1 divided by p is nothing but, so 1 by p is nothing but 1 by r into 1 divided by sin phi. So therefore it will be 1 divided by p is equal to 1 divided by r into cosec phi. Therefore it will be cosec phi. The next thing is we need to consider 1 divided by p square. So 1 divided by p square is equal to 1 divided by r square into cosec phi will become cosec square phi into cosec square phi. This is just we have taken, here we had r raised to m divided by r into dr upon d theta. So we have just taken 1 by r into dr by d theta is equal to, the equation is a raised to m cos m theta minus b raised to m sin m theta divided by, this is nothing but r raised to m. So this is nothing but r raised to m. So we have just substituted r raised to m. As we know that the r raised to m in the given equation, it is r raised to m is equal to a raised to m into sin m theta plus b raised to m into cos m theta. So we have just substituted this in the equation. So therefore 1 by p square is equal to 1 by r square into cosec square phi. So as we know that the cosec square phi can be written in terms of cot square phi as 1 plus cot square phi. So therefore 1 by p square is equal to 1 by r square into cosec square phi. 1 by r square into cosec square phi is nothing but 1 plus cot square phi. So therefore we can write it as 1 by p square is equal to 1 by r square into 1 plus. So then we need to substitute what is the cot phi. So cot phi, the value of cot phi we need to substitute. So we have obtained that cot phi. As we know that 1 divided by r into dr upon d theta is nothing but cot phi is equal to cot phi. So from the above equation, from this equation we can substitute 1 by r into dr upon d theta is equal to cot phi. So therefore the previous equation will be cot phi is equal to a raised to m into cos m theta minus b raised to m into sin m theta divided by a raised to m into sin m theta plus b raised to m into cos m theta. So now here 1 by p square. 1 by p square is equal to, so that is 1 by p square is equal to 1 by r square into 1 plus. So in place of cot square phi, we need to substitute the value of cot phi. We have obtained this value, that is cot phi is equal to this equation. We need to substitute in this. So therefore we obtain a raised to m into cos m theta minus b raised to m into sin m theta divided by a raised to m sin m theta plus b raised to m into cos m theta. It is cot phi. So here we have cot square phi. So it is whole square. So now we shall find the square of this. So therefore we have 1 by p square is equal to 1 divided by r square into. So and the next thing is, so here it will be square. So it will be 1 plus, so it will be a raised to m into cos m theta minus b raised to m into sin m theta the whole square. Then similarly it will be a raised to m into, we have been substituted the square on both numerator and denominator separately. So it will be a raised to m into sin m theta plus b raised to m into cos m theta the whole square. So then 1 by p square is equal to 1 divided by r square into. So here we need to find the LCM of this. So here it will be a raised to m sin m theta plus b raised to m cos m theta the whole square plus a raised to m cos m theta minus b raised to m sin m theta whole square whole divided by, it will be, this will be the LCM. So it will be a raised to m sin m theta plus b raised to m cos m theta square. So therefore we have 1 by p square is equal to 1 divided by r square into. So this is nothing but a raised to m sin m theta plus b raised to m cos m theta whole square. So the given equation was r raised to m is equal to a raised to m into sin m theta plus b raised to m into cos m theta. So this is the required equation which is given. So we need to reduce this pedal equation. So here we have a raised to m sin m theta plus b raised to m cos m theta. So just substitute in place of this with r raised to m. So it will be r raised to m whole square plus. So keep a raised to m cos m theta. So here we have a raised to m cos m theta minus b raised to m sin m theta whole square. Then after that, so this is nothing but, similarly this is a raised to m sin m theta plus b raised to m cos m theta. So this will be r raised to, same, it will be r raised to m square. Okay. So therefore here we can say that a raised to m sin m theta whole square, it will be b raised to m cos m theta whole square plus a raised to m cos m theta whole square minus b raised to m sin m theta whole square. So we can observe that. So here we have plus b raised to m cos m theta whole square. So then similarly here we have plus a raised to m cos m theta whole square and minus b raised to m sin m theta whole square. So then we can write it as, so in this b raised to m cos m theta and a raised to m cos m theta is there, so it will cancel. So remaining will be a raised to m sin m theta whole square and it will be plus b raised to m cos m theta whole square. So therefore we can write it in the form of a raised to m sin m theta. This is nothing but r raised to m. So r raised to m whole square. Similarly, we need to write it for b also. So it is a raised to m sin m theta whole square. So therefore it will be a raised to m whole square. Similarly for b it will be b raised to m whole square. So therefore it will be 1 divided by r square into. So if you multiply inside, it will be a raised to 2m plus b raised to 2m divided by r raised to 2m. Then 1 by p square is equal to 1 divided by r square into a raised to 2m plus b raised to 2m divided by r raised to 2 into m. then we can write this in the form of, so we can write p square is equal to r square into, so it will be r raised to 2m divided by a raised to 2m plus b raised to 2m. Then we can also write, here we have r square and here we have r square m, so therefore we can just write it as, we can take m common, so here also we have 2, here also we have 2, we can take 2 common, so therefore we can write the required equation as p square is equal to r square, we have taken 2 common, so it will be, if you take 2 common it will be m plus 1, so divided by a raised to 2m plus b raised to 2m. So this is the required Pradal equation, that is p square is equal to r square raised to m plus 1 divided by a raised to 2m plus b raised to 2m. So this is the required Pradal equation. Thank you friends, subscribe our channel for more updates.